In this video, we're going to look at some more examples of expanding logarithmic statements. And so we have this log base 7 of x squared y. And remember, if we have division, then what we're going to do is we're going to turn this into two subtraction statements. And so we're going to get this to be log base 7 of x squared minus log base 7 of y. And then, just like we've seen several times, we can move that exponent as a coefficient. And so we can write this as 2 log base 7 of x minus log base 7 of y. And that's probably the most simplistic that we can write that statement. Similarly, we have this log base 8 of the fourth root of x cubed y quantity z plus 1. So this is where we have to use this rule of exponents to rewrite the radical as a rational exponent. Okay, so we're going to start by rewriting this as log base 8. And I think we've seen this in one or two other videos, but that's going to be written as the quantity of x cubed y z minus, or z plus 1, excuse me, to the fifth, all raised to the 1/4 power. Okay, so if you have an index of 4, that just becomes a rational exponent of 1/4 power. And then what we can do is we can multiply all the exponents by the 1/4 power. And so our next line would look like log base 8 of x to the 3/4, y to the 1/4, because remember y has an exponent of 1, and then z plus 1 to the 5/4. And now we can write this as three separate logarithmic statements because we have multiplication among the three factors x, y, and z plus 1. And so our next line would be log 8 of x to the 3/4 plus log 8, or log base 8 of y to the 1/4. And then finally, plus log 8 of z plus 1 to the 5/4. And then the last thing that we can do is we could just take all of those exponents and we can move them down into the coefficient spot. So the 3/4, the 1/4, and the 5/4 are going to come down. And so our final answer would look like 3/4 log base 8 of x plus 1/4 log base 8 of y plus 5/4 log base 8 of z plus 1. And just was able to fit it on there. All right, so be careful when you're typing these into MyMathLab. Obviously, it's easy to make a mistake. This should be log base 8 of y, not log base 8 of 8. All right, so sorry about that, just a copy error. Okay, all right. In a similar fashion, now we have ln of x to the 7th, root y, z, third root of z squared. And so we're going to write this as ln x to the 7th. Remember, if it's a square root, there's an implicit 2 as the index, so this would be a 1/2. And then the third root of z squared becomes z to the 3/2. We can write this as three separate logarithmic statements: 2 multiplication, 1 division. All right, so we're actually going to use multiplication and division, so addition and subtraction. So this is going to be natural log of x to the 7th plus natural log of y to the 1/2 minus, because it's in the denominator, the z, natural log of z to the 3/2. And then finally, we can use the coefficient exponent rule of logarithms. So this will be 7 ln of x plus 1/2 ln of y minus 3/2 ln of z. Another example, we have log of the square root of 1,000,000x. And so the way that we want to write this is first to raise those both to the 1/2 power. So we can write this as log of quantity 1,000,000 x quantity to the 1/2. And then what we could do is we could move the 1/2 in front immediately, or we could break this up into two logarithmic statements, but I think we should just put the 1/2 in front. So we get 1/2 log of quantity 1,000,000 x. Then we're going to break it up into two logarithmic statements. So this is going to be because we have multiplication in here. So this now becomes 1/2 log of 1 million plus 1/2 log of x. And then you probably remember that if you just have a log without a base, there really is a base. It's the common logarithm 10, and we should probably try to evaluate this statement. Okay, so we could write log, and we could just say base 10 because it technically is base 10 of a million is equal to x, or in the exponential form, we would have 1 million equals x to the 10, or I'm sorry, 10 to the x, excuse me. And from there, what we would do is we would look at our calculators, or we just know what power that we need to raise 10 to be able to get to a million. So that'll be 10 to the x. And so we can go into our calculators, and we could just go ahead and see that 10 to the 6th power is going to give us our 1 million. Okay, so this will turn into 10 to the 6th equals 10 to the x, or 6 equals x. And so this statement, the log of 1 million, just becomes 1/2 of 6 plus 1/2 log x. And finally, we know half of 6 is going to be 3. So we can write this as 3 plus 1/2 log of x. Finally, we have this log base 3 of z cubed x minus 4, y minus 4 to the 7th. We're going to raise everything to the 1/2 power. Right? So this is going to become log base 3 quantity z cubed. Okay, so remember, anytime you have a square root, that's going to be your 1/2 power. So z cubed x minus 4 to the 1st power, and then y minus 4 to the 7th power, and that's all to the 1/2. And then just like we did before, what we could do is we could apply the 1/2 power to everything. And so we can write this as log base 3 of z to the 3/2, x minus 4 quantity to the 1/2 power. So again, 1 times a half is a half. And then finally, y minus 4 to the 7/2 power. We have multiplication and division. So we're going to go ahead and just put a positive for anything that's in the numerator, negative for anything in the denominator. We write this in the expanded form. So we're going to get log base 3 of z to the 3/2 plus log base 3 of x minus 4 to the 1/2, and then minus log base 3 of y minus 4 to the 7/2. And then finally, we could just use that rule where we just take all the exponents and we rewrite them as coefficients for our logarithms. And so our final answer is going to be 3/2 log base 3 of z plus 1/2 log base 3 of x minus 4 minus 7/2 log base 3 of y minus 4. And that should be it. Log 3 of y minus 4. And that's going to be our final answer for the expanded logarithm. All right, so in our next video series, what we're going to do is we're going to go the opposite way. And what we're going to do is we're going to take forms that look like this, our answer, and try to make them look like this form, okay, where we have the condensed form. And by the way, both of these are going to be useful when we start in the next section, when we start solving equations that involve logarithms, okay? So that's ultimately what we're trying to do, is we're trying to build up to that.